So let's start writing the code for topological sort using Khan's algorithm. So here we're gonna be needing graph, right? So I'm going to create a class graph, a static inner class, because I've already created a class named graph in this package. That's the only reason I'm creating it as inner class. So this graph will be needing the number of vertices and an array that can hold array lists. So this is an array which hold lists of integer. Let's call this adjacency array, and now we're going to create the constructor for this graph class, public graph, and this constructor is going to take the number of vertices as the parameter. Now let's assign this to this dot v. Now we're gonna initialize this array. So this is an array of list, so array list, and the size of this array is equal to the number of vertices Basically, this array is going to store the adjacency list of each vertex at the corresponding cell. So here we're going to take a for loop so that we can initialize each cell with a fresh array list. So here, this is a at j I equals to new array list. So we have created the constructor. Now we have to create a method to add the edges in this graph. So let's create a method add edge, and this will take int u, which is the source vertex, and int v, which is the destination vertex, as the edges are directed. And now here we are going to add v in the list present at u, right? So this is like if you're having edges, one edge which is directed from 1 towards 2, and you have another edge which is from 1 to 3. Then when you call this twice for these two edges, this will have a list at index 1 holding 2 and 3. Okay, so for 1 we will be having 2 and 3 in the list. Okay, now let's come to the main method and let's construct the graph. So graph g equals to new graph, and in the constructor we're gonna pass the number of vertices. Let's pass 6, and now let's add edges to this graph. So g dot add edge. Let's say the first edge is directed from 1 to 2, and second edge is directed from 1 to 4. Third edge is directed from 2 to 3, just like we had in the slides. And then the next edge is directed from 4 to 2, and another one from 4 to 3, and the last edge from 4 to 5. So now let's construct a method that will sort this. G dot topological sort, and let's create this method. So here in this method, the first thing we're gonna do is to create an array that will hold the int degree for each vertex. So let's call it this is array, int array int degree, and the maximum int degree any vertex can have is number v, as you cannot have more int degree than number of vertices, right? So now we're gonna take a for loop and we're gonna fetch the list one by one from the adjacency array, and we're gonna take that in temp. This is v, however both are same, but we can avoid recalculating it. So now here let's fetch the list present at ith index and let's take it in temp. So aj I, this is an array list, so let's say array list, and now let's cast adji to array list. So now we're gonna calculate the integer for each vertex. Okay, so let's take a for each. So for each integer vertex present in each integer vertex present in the temp array, we will take it and we will update the integer for it. So this is we're gonna do for all the vertices. So this will count the integer for each of the vertex and we'll store it in the integer array. So after calculating the integer, what we need to do, we need to get the one having integer 0, right? So we're gonna create a queue and we will see the node or the vertex having integer 0 and then we will add it to the queue. And there can be more than one vertex having the integer, so we will add those vertices in this queue. So equals to new linked list, and now we're gonna run a for loop from again 0 to v, and here we're gonna check if the integer of the current vertex is 0. If integer I is 0, then add it in the queue. Okay, so the work of queue here is getting the vertex with integer 0 and then keeping it until we add it into the result. And then again for the next iteration we'll do the same. It will have the next vertex having integer, and we are taking this count so that we can know the number of vertices we have already selected. Okay, so this count is 0. Now we're gonna add the element present in the queue from this queue to our result vector. So we're gonna take a vector that will store the result, vector integer. Let's call it linear order. New vector. Now we're gonna take all the selected vertices from the queue and we're gonna store them in this vector, which is linear order. So while the queue is not empty, poll the element from the queue. So queue.poll, and let's call this element that we are getting x, int x, and let's add this in the linear order. Now what we're going to do, we are going to see all its neighboring vertices and we're going to decrease the integer for those vertices, as we have deleted that vertex along with the edges coming out from it. So for each vertex present in the array list Adjx, remember Adjx itself is an array list, each cell is holding an array list. So the vertices that are present in this array list, for those vertices we're gonna decrement the integer. So vertex And if this integer, this new integer becomes 0, then we're gonna add these vertices in the queue so that they can be processed. Vertex, right? So after this, we will increment the count as we have selected the vertex. Now we have to check for if the graph contains a negative cycle, and you know that after selecting all the edges, the count will become equal to the number of vertices, that is, it will become equal to v. But if it is not equal to v, that means the graph contains negative cycle. So in that case, we're going to print that the graph contains negative cycle. Graph contains negative cycle. And if this is the case, we're gonna return from here without doing anything further. And if it is not containing negative cycle, we will print the final order, the linear order. So we are taking this for each to print the each index, each item present in this linear order, each vertex present in this linear order. So let's print this out, I plus space. So this is the complete implementation. Let's print the linear order as this. So this is complete. Now let's run this and see the order, and let's match it from the one we got. So this is the order that we got. Here we are getting 0. This is because I have taken 6 as the number of vertices to match this result with the explanation video, but we are only having 5 vertices, right? 1, 2, 3, 4, and 5. And as arrays start from 0, we are having that extra vertex at the top in the solution, but it's not having any mapping. So it's coming at the top. Now if we want to have only 5 vertices, we gotta replace these vertices 1, 2, 3, 4, 5 with 0, 1, 2, 3, 4. So let's replace them. If let's say we are only having 5 vertices, and if the name is 1, then change it to 0, 2 to 1, just decrement 1 from every number. This is 2, this is 1, this will be 3, 3, 2, and 4, and 3. Now let's rerun this to see the output. See, we're getting 0, 3, 1, 4, 2. This is equivalent to the result we were getting. If we add 1 to each one of them, we'll get 1, 4, 2, 5, and 3, which was the result. Okay, so this is how we can use Kahn's algorithm for topological sorting.